Hello viewers, in today's class we are going to discuss an important problem from relations and functions related to the concept of equivalence relation, right? So here we have this problem in which we are given a relation R which is defined on the set of rational numbers. So here the capital Q denotes the set of rational numbers, and if two elements A and B belongs to the set of rational numbers, then A and B are related if and only if this relation holds. That is, mod of A minus B is less than or equal to 1, right? And here we have to show that this relation R is not an equivalence relation, right? So what we will do before proceeding further, let us quickly revisit the definition of equivalence relation. Namely, here we'll see the definition of reflexive relation, then symmetric relation, and then transitive relation, right? So let us consider a set A, and let us consider the elements A, B, and C belonging to this set A, right? And if we define a relation, say R, on this set A, then this set A has the relation that is reflexive relation if each element of this set A is related to itself, right? So the relation R, which is defined on this set A, is said to be a reflexive relation if for each A, that is for each element A belonging to this set A related to A holds, right? So the relation R is said to be reflexive if for each A belonging to the set A is related to A, right? So it means each element is related to itself. Now, this relation R is said to be symmetric if we have A related to B. It means if we have two elements A and B belonging to the set A, and if A related to B implies B related to A, right? Then this relation R is said to be symmetric. So for the relation R to be symmetric, if A related to B, then B related to A, it must hold, right? And this relation R is said to be transitive if we have three elements, say A, B, and C belonging to the set A, and if we have A related to B and B related to C, if we have A related to B and B related to C, and these two implies that A related to C, right? So if A is related to B and B related to C, then this A must be related to this element C, right? So when this happens, then the relation R is said to be transitive, right? And in a set A, if all these three relations, that is reflexive, symmetric, and transitive relation holds, then we can say that this relation R is an equivalence relation, right? So in the given problem, we have to show that this relation R, which is defined as mod of A minus B is less than or equal to 1, it is not an equivalence relation, right? So let us start. So let us first take up the reflexive relation, right? So here we are given the set A as Q, right? So we have A is equal to Q, which is the set of rational numbers, right? Now we can see that the relation R is defined as mod of A minus B is less than or equal to 1, right? Okay, now if we have an element say A which belongs to our set Q, then we can easily see that mod of A minus A, right? Mod of A minus A is mod of 0, and mod of 0 is equal to 0, right? And this 0 is obviously less than a 1, right? So we can say that mod of A minus A is less than 1, right? And we can see that from this definition of relation R, that is mod of A minus B is less than or equal to 1. Here we have mod of A minus A is less than 1. So this implies that A is related to A for all A belonging to the set of rational numbers Q, right? So we have obtained A related to A. It means each element of this set Q is related to itself. So we can claim that this relation R is reflexive, right? Now let us consider the symmetric relation. So now to consider a symmetric relation, let us consider two rational numbers, that is A and B, belonging to the set of rational numbers, right? Now this relation R is defined as mod of A minus B is less than or equal to 1. So it implies that A is related to B, right? Which is our definition of relation R, right? Now if we take negative sign common from A minus B, then we have negative of B minus A here, and we can write less than or equal to 1, and we can easily see that mod of negative B minus A can be written as a mod of minus 1 times B minus A, which is equal to mod of minus 1 times mod of B minus A, and mod of minus 1 is equal to 1. So here we have 1. So this is 1 times mod of B minus A, that is mod of B minus A, right? So mod of A minus B less than or equal to 1 implies that mod of negative of B minus A is less than or equal to 1, and mod of negative of B minus A is equal to mod of B minus A, that is less than or equal to 1, right? So from this expression we can see that B is related to A, right? So we have obtained that when A and B belongs to the set of rational numbers Q, then A is related to B, and we have also obtained mod of B minus A less than or equal to 1. So it implies that B is related to A, right? So we have seen that A related to B implies that B related to A, which suggests that this relation R is symmetric, right? So R is a symmetric relation, right? Now let us consider the transitive relation. So now to consider whether this relation R is transitive or not, what we will do, let us consider three elements 1, 2 and 3 belonging to the set of rational numbers Q, right? Because 1, 2 and 3 are the three rational numbers, right? Now 1 related to 2 implies that mod of 1 minus 2 is less than or equal to 1, right? Which is true, because a mod of 1 minus 2 is mod of minus 1, that is equal to 1. So 1 is obviously equal to 1, right? And 2 is related to 3, because mod of 2 minus 3 is less than or equal to 1, and again mod of 2 minus 3 is mod of minus 1, which is 1. So 1 is equal to 1, right? So we have 1 related to 2 and 2 related to 3, right? So now let us see whether 1 is related to 3, right? Because in transitive relation, what we do, if we have three elements A, B, and C belonging to the set A, and if A related to B and B related to C exist, then these two must imply that A should be related to C. So now let us see whether mod of 1 minus 3 is less than or equal to 1, right? So mod of 1 minus 3 is equal to mod of minus 2, which is equal to plus 2, right? And we can see that 2 cannot be less than or equal to 1, right? So this is not possible, right? So here we can write this is not possible. So we can see that when 1 related to 2 and 2 related to 3, then we cannot have 1 related to 3, right? So this suggests that this relation R in the set of rational numbers when mod of A minus B is less than or equal to 1 is not transitive, right? So we can say that this relation R is reflexive and symmetric, but it is not transitive, right? And hence, this relation is not an equivalence relation, because we know that if a relation R is reflexive, symmetric, and transitive, then only the relation R is said to be an equivalence relation. But here, the relation R is reflexive and symmetric, but it is not transitive, as we have proved it not transitive by taking this example. So this relation is not an equivalence relation.